Look at the sheer scale of this machine. This is the Imperial Japanese Battleship Yamato. At over 72,000 tons fully loaded, it is the heaviest, most heavily armored, and most powerfully armed battleship ever constructed in human history. It was designed to be the ultimate apex predator of the ocean, a superweapon capable of sinking multiple American battleships simultaneously. But the Yamato held a dark, terrifying secret. It was a victim of its own impossible physics. When naval engineers push the limits of metallurgy and ballistics to this extreme, they cross a threshold where the weapon becomes a lethal hazard to the people operating it. The Yamato's main guns were so incomprehensibly powerful that the sheer concussive shockwave of firing them would instantly rip the flesh off any crew member standing on the open deck. The blast pressure was so violent that it literally crushed the ship's own secondary weapons, shredded its own reconnaissance aircraft, and forced engineers to add hundreds of tons of heavy armor just to protect the Yamato from its own firepower. This is the story of the ultimate megastructure of the sea. It is a deep dive into the terrifying physics of 18.1-inch naval artillery, the hydrostatic shockwaves that tore the ship apart from the outside in, and the tragic irony of a 72,000-ton fortress that was fundamentally designed for the wrong century. To understand why the Yamato was literally tearing itself apart, you first have to understand the monstrous mathematics of its primary weapons. In the 1930s, the international naval treaties restricted the size of battleships. The United States and Great Britain were building ships with 16-inch guns. Japan realized they could not outproduce the massive industrial capacity of the United States, so they decided to completely ignore the treaties and outgun them instead. They secretly engineered the 46-centimeter or 18.1-inch naval gun. The difference between a 16-inch gun and an 18.1-inch gun is not just 2 inches. It is an exponential leap in volume, mass, and explosive kinetic energy. The Type 91 armor-piercing shell fired by the Yamato weighed 3,219 pounds. That is the exact weight of a modern Honda Civic. To throw a Honda Civic 26 miles over the horizon, you need a terrifying amount of propellant. Each shell required 6 individual bags of cordite powder, weighing a combined 727 pounds. When that powder ignited, it generated over 43,000 pounds of pressure per square inch inside the firing chamber. The recoil from this explosion was so violent that the guns had to be housed in the most massive turrets ever built. A single main battery turret on the Yamato weighed 2,774 tons. To put that into perspective, one turret on the Yamato weighed more than an entire American World War II destroyer. But containing the internal pressure of the explosion was only half the problem. The real nightmare began the millisecond the shell left the barrel. When a naval gun fires, the expanding gases that push the shell out of the barrel exit right behind it. This creates a supersonic blast wave, known as muzzle blast overpressure. On a standard battleship, this blast wave is incredibly loud and concussive. On the Yamato, it was strictly lethal. Japanese engineers ran the math and made a horrifying discovery. When the Yamato fired its main guns, the muzzle blast generated a hydrostatic shockwave of 7 kilograms per square centimeter near the barrel. If a human being was standing unprotected on the deck anywhere near the forward half of the ship, the hydrostatic shockwave would instantly rupture their eardrums, collapse their lungs, and generate enough shear force to literally tear the clothes and skin from their bodies.
It created an operational paradox. The Japanese could not fire their ultimate weapon if their own crew was on deck. Before the main battery could be fired, a massive warning buzzer would echo across the ship. Every single sailor manning an anti-aircraft gun, every lookout, and every deckhand had to instantly drop what they were doing, sprint inside the armored citadel of the ship, and lock the heavy blast doors. But the crew wasn't the only thing the blast wave destroyed. During the ship's sea trials, engineers discovered that the overpressure was actually ripping the Yamato's own secondary infrastructure apart. The blast shattered the searchlights, it crushed the delicate optical rangefinders, it even ripped the ship's scout float planes right off their catapults. To fix this, engineers had to completely enclose all of the secondary armaments in heavy steel blast shields. This was a massive engineering compromise. By adding hundreds of tons of steel shielding high up on the deck just to protect the guns from the Yamato's own muzzle blast, they raised the ship's center of gravity, making it less stable in rough seas. The beast was so powerful, it was choking on its own strength. By 1944, the era of the battleship was over. The aircraft carrier had become the true king of the ocean. The Yamato was built to duel other battleships at 20 miles. Instead, it found itself being swarmed by hundreds of tiny, nimble American airplanes. The massive 18.1-inch armor-piercing shells were completely useless against an aircraft. So, Japanese ballistic engineers attempted one of the most desperate and bizarre ammunition hacks in military history, the Shiki, or Type 3, Beehive shell. They designed a specialized anti-aircraft shell for the massive 18-inch guns. Instead of solid steel, the Beehive shell was filled with 900 incendiary tubes and hundreds of steel splinters. The concept was to use the most powerful guns on Earth as the largest shotguns ever built. The Yamato would fire the Beehive shells into the path of incoming American bombers. The shell would detonate in midair on a time fuse, expanding into a massive, blinding cone of burning magnesium and shrapnel. It looked like the wrath of a god. But from an engineering standpoint, it was a catastrophic failure. The Beehive shells were a massive hazard to the ship itself. The sheer heat and friction of firing incendiary shrapnel shells severely degraded the delicate rifling inside the barrels of the main guns. Every time the Yamato fired a Beehive shell at an airplane, it permanently ruined the accuracy of its primary weapon. Furthermore, the explosion of the Beehive was highly visible, and it completely blinded the Yamato's own anti-aircraft directors, preventing them from tracking the real targets. In their desperation to fight an enemy in the sky, they had created a weapon that accelerated their own demise. In April 1945, the Yamato was sent on a one-way suicide mission to Okinawa. It had no air cover. Against it were nearly 400 American carrier-based aircraft. The Yamato had a massive 16-inch thick belt of hardened steel armor on its sides, designed to deflect the heaviest artillery in the world. But armor is useless if the enemy doesn't shoot at it. American pilots knew the physics of the ship better than anyone. They didn't aim for the 16-inch belt armor, they dropped torpedoes into the water, aiming specifically for the unarmored underbelly and the massive rudder. By heavily concentrating their torpedo attacks on the port or left side of the ship, the Americans intentionally destroyed the Yamato's center of gravity. The Yamato was engineered with a highly complex counter-flooding system. If it took water on the left, engineers would intentionally flood compartments on the right to keep the ship level. But the American torpedoes came in too fast, in too much volume. As the ship rolled past a 30-degree angle, the impossible weight of those 2,774-ton main turrets shifted. At 14:23, as the Yamato capsized, the massive forward magazines detonated. Over 1,000 tons of gunpowder ignited simultaneously. The resulting explosion was so massive that it generated a mushroom cloud that rose nearly 4 miles into the atmosphere. And the flash was seen 100 miles away. The greatest megastructure of the sea was instantly vaporized by its own ammunition.
The Yamato was not a failure of engineering. From a pure mechanical, metallurgical, and structural standpoint, it was an absolute masterpiece. It was a failure of timing. The Japanese engineers built the ultimate, perfect weapon for a 19th century war and sent it to fight in the 20th century. It was a ship so powerful that it had to fight the physics of its own blast waves, a machine that ultimately died because it could not adapt to a changing world. So, here is my question for you. Does the Yamato deserve to be remembered as the pinnacle of naval engineering, or was it the biggest waste of steel in military history? Let me know in the comments below. And if you want to know how the rules of war are changing today, with $2 lasers shooting down drones, you need to click the Iron Beam video right here. Hit subscribe. I'll see you in the next one.